Hello, beautiful people, and welcome. In this video, we are shifting from right triangles into right triangle trigonometry. So the first thing we need to know is there are these ratios. Ratios is just a fancy word to say fractions. So we have these fractions that depend on how we label a triangle, and where in the triangle is something called our theta, our eyeball, our angle. So let's start with labeling a triangle. When you have a right triangle, your capital C is always going to be at your 90-degree angle. Now, across the street from C is a lowercase c. This lowercase c represents the side opposite the angle. Now, just like when we are doing the Pythagorean theorem, your A and B's don't really matter. What does matter is that a capital A is across the street from a lowercase a. So let's make A here. It doesn't really matter which angle is A, as long as the capital letter is across the street from the lowercase a. Now, we have left over is B. And again, B has to be across the street from a lowercase b. Capital letters represent angles. Lowercase letters represent sides. So let's talk about our eyeball. So the eyeball, theta, is typically used to indicate an angle. Now, it's not always going to be theta. It can be, majority of the time, some sort of Greek letter like gamma. Sometimes you'll also see x as an angle. So what that means is when you have an angle, let's say angle A, sometimes you're going to see that A is going to be a theta. Sometimes you'll have an angle here, B, and sometimes B will be your theta. And sometimes you'll have your theta being here. Let's make it an A again. You will not have your theta, you will not have your eyeball at the 90-degree angle. It will only be on your A or on your B. So why does this matter? The theta, the eyeball, tells you whether you're opposite or you're adjacent to a side. So if, for example, our theta is here, this is your eyeball. Let's draw the eyeball. Let's draw eyeball like that. The eyeball's looking. You can tell I'm not an art teacher. That's okay. But we're looking this way, right? So out of the point of view of theta, the across the street, lowercase a, little a, this is your opposite because it's opposite a. Now we have the adjacent. Well, we have two options. Well, which one's next to a? Well, both are next to a. We have this side and this side. So the catch is that the side opposite your 90-degree angle is always your hypotenuse. Now, if you're in my class, you already know this, that hypotenuse is written as hippo. It's funner that way. So that means you're left with just this third side. And this third side is going to be your adjacent. Your adjacent. Now, this just happens to be your lowercase b in this example. In every single example, all of this will change. The only thing is the hypotenuse will never change. Your hypotenuse, let's keep it in pink, will always be across the street from your right angle. This is always going to be your hippo. This is always your hypotenuse. Your A's and B's and your theta and your eyeball, your opposite and your adjacent will switch. Your opposite and adjacent will switch depending on where you have your eyeball. So if B is our eyeball, across the street from our eyeball is your opposite. And that means that this side right here next to B is your adjacent. Let's try this again. If A is our eyeball, across the street from A is your opposite. I'm going to write op since I'm running out of space here. That means the adjacent is going to be here. Now, it's really important for you to know how to label your triangle. The opposite, hypotenuse, adjacent will come back in just a few seconds. The ratios of trigonometry, of right triangle trig ratios, they are fractions. Now, these fractions depend on the placement of your eyeball. We'll call it theta. And again, theta is just an angle, and we call that angle our eyeball. So it all depends on where your eyeball is. You move the eyeball, the ratio change, the fraction will change. Now there are 6 right triangle trig ratios. I already kind of wrote this out here. This right here you will be memorizing. Memorize. And sometimes you're going to see it written a different way. So we are going to name all of these. This is so, ka, toa. I personally will always write it as SOHCAHTOA, like words like SOH, CAH, TOA, but sometimes you're going to see it written like this. This is SOHCAHTOA, SOHCAHTOA. Now, what is SOHCAHTOA? SOHCAHTOA tells us the ratio. This tells us the ratio. And again, ratio is just fraction. That is specific to a triangle. And we can even say it's a unique to a special triangle. And it's theta. So if I tell you that the sine of theta is 3/5, 3 means something, 5 means something. That is very specific to a specific triangle and where that eyeball is in that triangle. So let's talk about SOHCAHTOA one more time. The S represents sine, S-I-N-E. The O represents the opposite side. The H represents the hypotenuse. The C represents cosine. And one more time, make sure that you have an eyeball. So this sine of an eyeball, cosine of an eyeball. And the A represents adjacent, and the H represents the hypotenuse. T represents tangent. And again, we need our theta, we need our eyeball, and tangent is opposite over adjacent. Again, we're just creating fractions. What is trigonometry? Right triangle trigonometry is creating fractions. Telling someone where an eyeball is, telling the reader what you see through that eyeball. Now, mathematicians, you already know this in my class, mathematicians are lazy. So we are too lazy to write out the entire sine, cosine, tangent, so we abbreviate. So instead of writing sine, we write sine without the E. This is not sin, you're not in church. This is sine. So although we abbreviate, we actually say the entire word. Like cosine is abbreviated COS, but we still say cosine. We still say the full word. Tangent is TAN, but again, we say the entire word. We say tangent. Now, it's weird because it says name all 6. Right now, we only have 1 ratio, 2 ratios, 3 ratios. What are the other 3? Well, the other 3 are called the reciprocal functions. Reciprocal functions. Or you can say ratios, not rations, ratios. There should be an S. Now, reciprocal means you flip the fraction. So when you flip the fraction is you take the bottom and the top and you replace them with each other. So your denominator becomes a numerator, your numerator becomes a denominator. So if, for example, you have, let's list this out, sine of theta, cosine of theta, tangent of theta. I'm going to write this in a thinking bubble because every single time we deal with right triangle trigonometry, we're going to be dealing with so, ka, toa. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. The reciprocal ratios is us taking sine and flipping it, taking cosine and flipping it, taking tangent and flipping it. So if I flip sine, I have 1 over sine. If I flip cosine, I have 1 over cosine. And if I flip tangent, I have 1 over tangent. If I flip sine, cosine, and tangent, that means the ratio, the fraction that I originally had, they also get flipped. So we have h over o, hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. Now again, mathematicians are lazy. So if we take the reciprocal, I don't want to say, well, 1 over sine of theta is hypotenuse over opposite. We are actually going to create a new word for that. The easiest one to remember, in my personal opinion, is cotangent. And cotangent is represented as COT. This is pronounced cotangent. Now, sine and cosine have been flipped, right? 1 over sine, 1 over cosine, h over o, h over. So in my opinion, this is the way that I remember it. If it starts with a C, it goes to an S. So this is SEC of theta, which this one is pronounced secant. And again, C goes to S, so therefore S goes to C. Let me change color here for you. And this is called cosecant. CSC. This is called cosecant. Cosecant. And so not only do we have 1, 2, 3 right triangle trig ratios, we also now have 4, 5, and 6. So how do we use the right triangle trig ratios? The step number 1 also, there should be a right triangle. Step 1 is always label your triangle. Now what does that mean? That means your ABCs and your hypotenuse, your adjacent, and your opposite. You want to label all of it. Get all of that out in the open so when you see it, you already know what your ABCs are, what your opposite is. Start with your hypotenuse, go across the street. And I think I said start with your hypotenuse. Start with your right angle, right? Start with your right angle, go across the street, that's your hypotenuse. Then, depending on where your eyeball is, if this is your eyeball, across the street from your eyeball is your opposite. That means next to it is your adjacent. C, the letter C, is always your hypotenuse. And across the street from your hypotenuse is your angle, that's a right angle. Then we have your A's and B's. It doesn't matter where your A's and B's are, as long as A is across the street from A and B is across the street from B. Once you have them labeled, then you can identify sine, cosine, and tangent. So let's do that. Sine of theta, cosine of theta, tangent of theta. Well, what are they? We're going to write, kind of off to the side, let me use this here. So, toa. That means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I'm going to write that out. Opposite, hypotenuse, adjacent, hypotenuse, and opposite over adjacent. So that means that I'm going to have a fraction for each one. Here's my eyeball, right? Here's my eyeball, here's my theta, here's my angle. Opposite of my eyeball is the number 3. Hypotenuse is the number 5. Adjacent is the number 4. Hypotenuse is the number 5. Opposite is the number 3. Adjacent is the number 4. So that means, I'm going to shift it here, sine of theta, the ratio of opposite over hypotenuse when you are looking through the eyeball of theta is 3 over 5. Cosine of theta is 4 over 5. Tangent of theta is 3 over 4. These are your 3 trig right triangle trig ratios or your fractions. So we have a few triangles here. Let's go ahead and I'm trying to see. I'm going to go ahead and skip that for just a moment here. Let's go ahead and do one more example for all of our trig ratios. So let's do sine of theta, cosine of theta, tangent of theta. Now they want all 6, so we have to have the reciprocal ones, which is cosecant of theta, secant of theta, and cotangent of theta. If you write out SOHCAHTOA, you already know what your fractions are. So we have oh, you guys can't see that, toa. And that looks a little weird, but that's okay. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, but they don't have these in SOHCAHTOA, the cosecant, the secant, and the cotangent. That's okay because we know that they are reciprocal functions, which just means you flip the fraction. So let's find out these 3. Let's label our triangle. Across the street from the 90 degrees is your hypotenuse. Here's our eyeball. Here's your theta. Across the street from that is your opposite. And here is your adjacent. So that means opposite is 8. Hypotenuse, we don't know the hypotenuse. That's okay. Because if we have a right triangle, we have the Pythagorean theorem. And the Pythagorean theorem says if I have a squared plus b squared equals c squared, then I can find my hypotenuse. So 12 squared plus 8 squared equals c squared. I'm going to type that into the calculator real quick. Let that do the work for me. 12 squared plus 8 squared. That gives me 208. I'm going to take the square root of that. And that gives me c is about 14.5. We'll just round it to 14 to a whole number. So we have 14 as our hypotenuse, about. Again, I am rounding to a whole number. Cosine Cosine, where's cosine? Cosine is adjacent over hypotenuse. Adjacent is 12. Hypotenuse is about 14. Tangent is opposite, which is 8. And adjacent, which is 12. Now I'm going to go in and simplify these fractions. You want to make sure to simplify all of your fractions all of the time. If you need to rationalize the denominator, please rationalize the denominator. So we have here 4/7 simplifying. Then we have 6/7, and we have 2/3. Now that we have our sine, cosine, tangent, we can flip those reciprocals. Sine S goes to C, C goes to S, and tangent goes to cotangent. And again, these are reciprocal, which means you flip the fractions. So once you have sine, cosine, and tangent, all you have to do is flip the number in your set. So you have 7/4, 7/6, and 3/2 as your fractions. Let's go back real quick to these here that we wanted to do. It says identify all of these 6 trig ratios. I'm going to do these 2 on a separate sheet of paper. It gives me a little bit more space. So we have a 45, 45, 90 triangle. We have 1, 1, and this is what? √2. This is your 45, 45, 90 triangle. And our 45, 45, 90 triangle, if you remember our special triangles, that means we have x, x, and x √2. So if we have x is equal to 1, that means we have 1 times √2, and that's our hypotenuse. It is asking us for all of our trig ratios, so we have sine of theta, cosine of theta, and tangent of theta. Again, SOHCAHTOA, I'm going to write here. Sine, oh, we don't know where our eyeball is. Let's make our eyeball here since I already did that. Here's our theta, here's our eyeball. That means we have an opposite. That means we have a hypotenuse here. Across the street from 90 degrees is always your hypotenuse, and this is your adjacent. So sine of theta, right here, we know what theta is. Theta is not an unknown measure. We know what degree that is. And that degree is 45. So I'm going to say sine of 45, cosine of 45, and tangent of 45. Then, because we know what our angle is, we can figure out our ratios with SOHCAHTOA. Opposite over hypotenuse, opposite is 1, hypotenuse is √2. Going to need to rationalize that denominator here, but that's okay. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that means I'm going to multiply √2 top and bottom. And only I'm doing these so I can rationalize the denominators. I have a √2 over 2, √2 over 2, and this one I have 1. So that means sine of 45 degrees is equal to √2 over 2. Cosine of 45 degrees is equal to √2 over 2. And tangent is equal to 1. Now I'm going to skip the reciprocal functions just right now for the sake of time. I feel like this video is getting a little bit on the longer side. Let's do a 45, 45, 90, excuse me, a 30, 60, 90 triangle. Here's 30, here's 90, here's 60. This is your x, this is your 2x, and this is your x √3. If we're having our eyeball here, so this is where it does matter where your eyeball is, because theta is at 30. So when we write sine, we're going to say sine the fraction, the fraction when we look through the 30-degree angle, the fraction when we look through the 30-degree angle, and the fraction when we look through the 30-degree angle is different than the fractions when we look through the 60-degree angle. So here are our labeling. So here's the opposite. It's opposite from 30 degrees. Here's your hypotenuse, and here's your adjacent. Now, just like we did in the previous example, we're going to make x equals 1. So if this is 1 times root 3, and this is 2 times 1. So that means this side is 1. That means the long leg is simply root 3, and that means that the hypotenuse is 2. Again, SOHCAHTOA. For SOHCAHTOA, we have opposite, which is 1, over hypotenuse, which is 2. Cosine is adjacent, which is root 3, over hypotenuse, which is 2. So far, we do not need to rationalize any denominators. Tangent is opposite, which is 1, over adjacent, which is root 3. So this tangent, we do need to rationalize the denominator. I'm going to multiply top and bottom by root 3, which gives me root 3 over 3 as the answer. So tangent of 30 degrees is equal to root 3 over 3. Cosine of 30 degrees is equal to root 3 over 2. And sine of 30 degrees is equal to 1/2. Something that we're going to talk about a little bit later on in our unit is that these things you will have to memorize all of these. Like this value, you're gonna know by heart. Thank you for watching my video, and I will see you next time. Bye! Thank you for watching my video, and I will see you next time. Bye!